All right, so last time we went through the whole unit circle, and I told you guys to make sure you learn that forward and backward, and so hopefully that's what you've done. Today we're going to work on sine and cosine function graphs, and so we're going to start with the sine. It tells us here that in this unit we've already learned how to define the sine and cosine values for angles in standard position, how to measure angles in radians, and how to use the unit circle to evaluate sine and cosine functions at given angles. We're now going to put all of those ideas together in order to represent these sine and cosine functions. And we'll start with the sine of theta. So I've got some tables created here with all of the important angles from the unit circle going all the way around. I have gone ahead and done the favor of making those decimal values so that you can graph them onto your graph. But go ahead and pause the video, see how well you know that unit circle, and come up with all of those sine values for each of the angles on the unit circle. All right, so here's all the values that we got for those angles on one time around the entire unit circle. So an entire time around the unit circle goes from 0 to 2 pi, so we found all of the angles all the way around that. Now, again, I gave you those decimal approximations because it is easier to use those to graph. So go ahead and plot those points on your graph so we can see what that sine graph looks like. Here's what your sine graph should look like. So I've gone ahead and plotted our points there, and then I've connected the dots to get our sine graph. So this would be one full cycle around the unit circle. If you remember from the first section of this unit, we called that periodic. It's a periodic graph because it starts here, it increases, and then it decreases down here and starts to increase again. Now, as we made another circle around the unit circle, this would continue to follow this same pattern over and over again. We talked about those coterminal angles. So once we go around that unit circle one time, then we're going to end back up at these as we move forward. So 2 pi plus pi over 6 would get me right back here. 2 pi plus pi over 2 would get me right back over here. Those points fall on top of each other and continue that pattern forever. So that's what our sine graph looks like. It starts right here at 0, 0, increases, decreases, and then goes back to 2 pi. It is considered, again, a periodic function because it does follow that pattern over and over again. What we just graphed was one cycle or one period of the sine function. As we travel around the unit circle, then we'll see another period every 2 pi. So the period for our basic sine function is 2 pi. That means it starts, one full cycle goes, and it ends at 2 pi. And every 2 pi, we will see another one of these full cycles. The midline is the halfway between the maximum and minimum values. So it's this line right here. In this case, it is the x-axis. That's going to be our midline. So we call that y equals 0 because it is a horizontal line. So you should have the y equals there, and the y value there is 0. Amplitude is the distance from the midline to the maximum or the minimum. So we see that right here from our midline to the very top point, it is 1 unit long. And from the midline to the very bottom point, our local min and max there, that's 1. So our amplitude is 1. Some people like to refer to it, the total distance is 2, and you would divide that by 2. So that's going to give me that 1. So your total distance divided by 2 will also give you your amplitude. You'll start seeing it in different ways like that. The frequency is the reciprocal of the period. So we flip this, getting it 1 over 2 pi. The frequency is the number of complete cycles that occur within a specific time frame. So that's what our frequency is telling us. The graph of f of theta equals sine of theta oscillates between the concave down and concave up. So we're going to have to use all those characteristics that we learned in Unit 1 to describe these graphs. We see that it is concave down on this section and then concave up on this section. Our graph is increasing here and here, and then decreasing from here to here. So all of those terms that we talked about, that vocab we used in Unit 1, we're going to continue to use that as we talk about graphs, in particular our sine and cosine here. All right, so what we just did for our sine, we want to do for our cosine. So again, recall that unit circle, and go ahead and put in the cosine value, and it tells us exact there for all of the important angles on that unit circle. Again, I've given you the decimal approximation so that you can plot those points. So here's our values from the unit circle for cosine. Remember, cosine is the x values. So at pi over 6, our x value is root 3 over 2. And so on for all of these values. There's a decimal approximations. So go ahead and take a minute to plot these points on the graph, which is on that next section there. So plot your points so we can see what that cosine graph looks like. All right, so we should have a graph that looks like this for our cosine. Notice that the sine started here at 0, but remember the cosine of 0 is 1. So that one is starting up here for our first period of the cosine. And then it decreases until we hit -1 at pi, because the cosine value at pi is -1. And then it starts to increase again till we're back at 1. Now that occurs at 2 pi. So again, one period of this graph is 2 pi, which is one time all the way around the circle. So that's what our plot looks like. Let's talk about some of the characteristics here. We just said the period is 2 pi because it goes from 0 to 2 pi to get one complete cycle of this graph. Our midline is the x-axis again, so it's y equals 0. Our amplitude is still 1 from the midline all the way to the bottom, and from the midline to the top, it's 1 unit long. So that's our amplitude, and then our frequency is at 1 over 2 pi. It too oscillates between concave down and concave up, even though with only drawing this one period, it doesn't show it as well. But if we followed that all along, then you could see both sides. This would be our concave up. And then we would have our concave down over here and concave down over here. And we'll talk a little bit more about concavity in a second. Let's talk about the sinusoidal functions. It tells us is any function that involves additive and multiplicative transformations of sine of theta. That means that the sine and the cosine functions are both sinusoidal functions, because g of theta is equal to cosine of theta, which is equal to the sine of theta plus pi over 2. If you remember your transformations, we've talked about transformations a lot this year and last year. This is on the inside here. So this is a horizontal translation of negative pi over 2. It is going to the left, pi over 2. What that means is if we took this graph right here and we moved it to the left pi over 2, then this graph would start right here. And we would be having the sine curve again. So they both would end up in the same exact spots. You can see that from the table as well. On our sine graph right here, when you look at these points here, and then you compare them to the cosine values, they're all the same numbers, just shifted over a little bit. So we consider both the sine and the cosine sinusoidal functions. That's going to become important in a few places. The first one is going to be on your calculator. We will see later on in this unit that when you do the regressions for trig functions, you're only going to see the sine regression. That is good for both of these. Since it's just a transformation, we can have it move it over. Now, when you go graph these on a calculator, make sure that your mode is in radians and that your window's set up for x values going from pi. So a good window for this would be from 0 to 2 pi. If this is all I wanted to see, my x values would go from 0 to 2 pi. My y values would go from -1.5 to 1.5. That's what this window is right here. So you're going to want to match that on your calculator. And we'll get more into that as we move forward on other ones and right equations next time. Today is just an intro for that. So the next thing we're going to talk about is the increasing, decreasing, and concavity. So here's some of those characteristics for our graph. And so it tells us to just look at the interval from 0 to 2 pi. So we're only looking at one period of the sine graph, or one time around the unit circle. And so the first thing we're going to talk about is increasing and decreasing. So I'm going to go ahead and highlight here where it is increasing. That is in the spaces right here. Now remember, when we write intervals, we write the x values. So I'm going to say from here to here is where it's increasing, and then again from here to here, those x values. So from 0 to pi over 2, and then again from 3 pi over 2 to 2 pi. Let's talk about that on the unit circle next to it where it says the sine of theta increases on. So we just said from 0 to pi over 2, so that is this section right here. Our sine values are increasing. Now we know sine is y value, so we could see that that's increasing right there. And then we see it would decrease as it goes this way, and then it starts to increase again. So from 0 to pi over 2, and then from 3 pi over 2 to 2 pi. That's where our sine increases. Those are the intervals. All right, for decreasing, we said that occurs in between. So from pi over 2 up to 3 pi over 2, all of this part right here is decreasing. That is from pi over 2, which starts right here, to 3 pi over 2. So all of this is decreasing. Again, we write our x values, so we're going to say from pi over 2 to 3 pi over 2. That is where sine decreases. All right, now for the concavity, I'm going to go ahead and highlight again the concave up. And so I can see on my graph here, it is concave up. That's opening upward. It is concave down on this side where it's opening downward. That interval is going from pi to 2 pi. So the sine is concave up from here to here. All right, for concave down, we see that's from 0 to pi, so that's going to be this top part of my unit circle. It is concave down. And so that is from 0 to pi. So that's some features for our sine curve. All of those vocab words from Unit 1, you're going to have to be able to describe our graph with that. Now let's look at the cosine ones. So for my cosine graph, it's going to decrease starting right here all the way to the bottom, and then it increases here. So I'll go ahead and highlight the increasing part. This is the part that's going up. Remember, we read graphs from left to right. So it is increasing from pi to 2 pi. Let's go ahead and highlight that on our unit circle here. And that is from pi to 2 pi. Our graph is increasing. And that is for the cosine. All right, for our decreasing, it started at 0 and went all the way to pi. So it's going to be this top part right here. Since these graphs are periodic, then that means every 2 pi will start right here again and do this increasing part forever, since that is going to repeat. All right, for concave up, we can see this bottom part right here is what's opening upward. This part would be concave down, and then this part would be concave down as it continues there. And so our concave up is from pi over 2 to 3 pi over 2. And then we've got a concave down from 0 to pi over 2, and from 3 pi over 2 to 2 pi. So concave up is going to be from pi over 2 to 3 pi over 2. And then from 0 to pi over 2. And from 3 pi over 2 to 2 pi. That must be written in two intervals, or then you would say these values are included. So you can't just say all the way around. We want to split it up into the two intervals from 0 to pi over 2, and then again from 3 pi over 2 to 2 pi. That's when it's concave down. All right, in both of these cases, the sine and cosine, remember they're periodic. It is going to repeat, so you will be increasing and decreasing in several parts on the graph as it continues through that period. All right, so the last part of what we're going to do today is going to relook at our FRQ questions. And so we said in AP Pre-Cal, the AP FRQ questions are always going to be written somewhat like this. So our FRQ3 is always going to be some form of a sine graph. It's going to give us a scenario for us to go through. We're going to write the points on the graph. The part that we were missing from this first section of the unit is this part right here with the period, frequency, and amplitude. So that's what we're going to add to our FRQ here. So it says the figure shows a large clock mounted to a vertical wall. The clock has an 8-inch long moving minute hand. I like to write what I know here, so I'm going to go ahead and label that as 8 inches from the center to the top. The center of the clock is 120 inches directly above the floor. And so here is my floor. And so if I'm 120 inches, that's going to be this portion right here to the center of the clock. So that's lining up right there. At time t equals 0, the minute hand is pointed directly up at the 12. So that's telling me this part right here is where we're starting. That's where t is equal to 0. Then it says the clock is not working properly and the minute hand is moving twice as fast as it should. Thus, the next time the minute hand points directly up to 12 is at 30 minutes. So 1 revolution is going to be equal to 30 minutes on this clock. As the minute hand moves, the distance between the endpoint of the minute hand and the floor periodically decreases and increases. So as we start up here and it starts to go down, then the distance to this floor is going down. It's decreasing until it hits here. This is the closest it's ever going to be to the floor. And then it starts to increase again until it gets to the top, which is the furthest it's going to be from the floor, or the highest. As the minute hand moves, the distance between the endpoints of the minute hand and the floor periodically decreases and increases. The periodic function h models the distance in inches. So now we know h is the distance in inches between the endpoint of the minute hand from the floor and the floor as the function of time t in minutes. So our points are t, h of t. So t is the time that's going to represent my x values. The height is going to represent my y values. It says no scale is indicated, no axes are presented. So we don't know that any of, or what it's saying is none of these are the x or y axis. It is just a part of the graph somewhere. The x-axis could be below it. It could be above it, anywhere. So we really need to think about what's going on in this scenario. Now we said at t equals 0. So when we are starting this, my hand is right here, which is at the highest point it will ever be, that furthest distance from the floor. And so it is 120 inches to the center plus the 8 inches of the hand. So that would be at 128. So at 0, it's at the max. Well, these are clearly my max values here. These are my min values. And then this would be the midline. So I know this is going to be 128. And I know this is going to be 128. That's the highest it's ever going to be. Now, we did say it started at 0, so this one's probably easier than the other ones you've had in the fact that that first point starts at 0. That's not going to be the case all of the time. And it said 1 revolution is 30 minutes. So that's our period there. So 1 time that it goes closer to the floor and then comes back up from the floor takes 30 minutes. So I know my time here is 30. Now, the closest I'll ever be to the floor is when it's right here. So as this moves around, so then we know this bottom value here is going to be 112 because my center is here at 120. The lowest it's ever going to be is when this goes all the way around and it's 8 inches lower, which would be the 112. So I know the y value here is 112. Now, the midline is exactly what it sounds like. It's directly in the middle, and it told us that the center of our clock was 120 inches from the floor. So I know my y value here is going to be 120. Now, remember, that's 1 point for you to have the y values. So even if you can't figure out the x values, go ahead and try and get those y values there, or vice versa if you can figure out the x's and not the y's. To get the other point, we need the full points. So from 0 to 30 was one period of this graph. Well, this bottom part has to be directly in the middle of these 2 points, making this 15. And then this one has to be in the middle of those 2 points, so that would make this 7.5. And then 15 plus 7.5 gives me 22.5 for that one there. And so there's our 5 points on our graph. Now we use those 5 to find the period, the frequency, the amplitude, and the midline here. Let's start with amplitude. We said for amplitude, you are looking from the midline up and from the midline down. In this case, that's the length of our second hand there, which was 8 inches. So we went 8 inches up and 8 inches down from that midline. So this would be an 8. For the next portion, we'll do the period. The period is one full cycle of this graph, so it goes down and back up, and so that was 30. The frequency, we are just doing the reciprocal of that, so it would be 1 over 30. And then our midline is going to be y equals, because it is a horizontal line, and that y value there is 120. Now it says find 2 intervals for which the graph of h is both decreasing and concave up. Well, we can see this right here is decreasing and concave up. So we can say on the intervals, 7.5 to 15, and now we need to come up with another one. And so it is not on this graph. There's no other point in this section that I have graphed here with points that show it, but I know that the period is 30. So every 30, I should be at the same spot. So 30 from this point, I will be right there again. And so at 37.5 would be right here. And then this portion would be decreasing and concave up. So 37.5 to 45. The graph of h is both decreasing and concave up. So that's how we would want to answer that. Again, that's using the period, knowing what we do about how these graphs work from our periodic phenomena in order to answer it. All right, so let's look at some of these graphs just to make sure that we're able to get that information from it. It says 2 periods of the sinusoidal function f of theta are shown in the figure above. Find the period, frequency, amplitude, and midline for the graph of f of theta. So here's my graph of f right here. It is showing 2 periods. It tells us 2 periods right here, which is good so that we can see a little bit more than that 1 period. So it is a sine graph, starts right here, goes up to this point would be 1 period, and then it repeats, there's that second period. So that repeating of the pattern is where we find that period distance. So from here to here is what we're calling 1 period. That's where the pattern starts to repeat. So the distance from here to here, that's from 0 to pi. So the period on this one would be 1 pi. Our frequency, we said, is the reciprocal, so I just flip that. The midline is a horizontal line, so I'm going to say y equals. And so our midline would be right here where it breaks our sine curve in half. And so that is at 3 right there, so we would say y is equal to 3. Now the distance from the midline to the top is 3 units, or from the midline to the bottom is 3 units, so our amplitude is 3. Again, you can look at it, the whole graph goes 6 units, and so divided by 2 is 3. All right, let's look at another one here on graph G. You can find the period using any point. So you can start from this point to this one, or you could say from this one to this one. Since it is repeating anywhere on the pattern, you should be able to find the values. I can say from this one down here to this one, that would be 1 period as well. That's where our pattern begins to repeat. I do think this is the easiest spot to spot it on this one. So it's from 0 to pi over 2. So my period is pi over 2. Frequency is the reciprocal. So I flip that. The midline in between these. So this is at -1, this is at +3. So this is 4 units in total. And so from the midline would be 2 up and 2 down. So my amplitude is 2, and my midline would be at that y equals 1. All right, when they give you the graph, really pulling that information is the easiest way to do that. But if you're not given a graph, you're really going to have to go think of that graph in your head. It gives us here that a maximum is at pi comma 8, and the minimum after reaching that maximum occurs at 3 pi comma -2. They want us to find that information. So think about what's happening here. So this is a maximum, this is a minimum. So it says the maximum occurred at pi over 8, so a point that looks like this, and then the very next minimum happened at 3 pi minus 2, comma -2. So from pi to 3 pi, we went a distance of 2 pi. That's only half though, because they gave us a max and a min. We can see that's half of my curve. I need to get back up here for the full period. So from pi to 3 pi was 2 pi. I double that, and so the period here is 4 pi. The frequency is the reciprocal, so I get 1 over 4 pi. Now for the midline, that's where I look at these y values. So I've got one at -2 and one at 8. These are 10 units apart. So half of that would be 5, which is my amplitude, which means that the midline needs to be up 5 from this and down 5 from this. So we find that at 3, so we write the midline is y equals 3. So today was a big intro into that sine, cosine. Hopefully you got good at seeing what it looks like, what the period is, what its characteristics are. Watch our next videos here for the transformations and writing the equations.